This section is about the derivative. You will see that in calculus, derivative is very important. The tangent line to the curve, we introduce a tangent line in section 2.1. However, this time we have a better tool to find the slope. So as you can see right here, the slope is defined as the limit. Now, let's take a look at example 1. Hopefully you still remember example 1, which is the parabola x squared, and then we want to find the tangent line at the point P 1. Now, like I said, in 2.1, we pretty much just used approximation, but this time we have the definition, which is the slope is the limit as x approaches a. In this case, a is 1. F of x is x squared minus f of 1. F of 1 is just 1. So as you can see, we have x squared minus 1 over x minus 1, which is x minus a. All right, make sure you don't use direct substitution right away, because as you can see, if you plug it in 1 minus 1, it's going to be 0 on the bottom. We don't want that. So first, let's factor it out. So after I simplify, I ended up with the limit as x approaches 1, x plus 1, which is 1 plus 1, which is 2. Now we have the slope of the tangent line. So we're going to plug it in the equation. So I always use y equals mx plus b, plug it in for y and x, plug it in for m, and then solve for b. However, if you want to use the point slope form, that's fine too. So y in this case is 1, the slope is 2, x is 1 plus b. So 1 equals 2 plus b, therefore b must be negative 1. And then we use that, we plug it in, y equals 2x minus 1. And we have our the equation of the tangent line at the point 1, 1. Now, moving on to a different expression of the slope. This time, we let h equals to x minus a, and then the slope is defined as follow. Right here, still the limit. Okay, so let's take a look at a different example. Now this time we have the hyperbola, which is y equals to 3 over x, and at the point 3, 1. So let's find the slope of the tangent. So we need the slope of the tangent at 3, 1. Okay, I'm going to use the new expression instead. So we have the limit as h approaches 0, f of 3 plus h minus f of 3 over h. Okay, so now let's take the limit. So is the limit as h approaches to 0, and because the function is y is 3 over x. So what I have for the first expression is going to be 3 over 3 plus h minus 1. Because f of 3 is 1. It's 3 over 3, so it's 1 over h. All right, so let's simplify it. We have, I still have to write limit as h approaches 0 every single time. So doing some algebra, we have the LCD, so I'm going to have 3 minus 3 plus h over 3 plus h over h. Okay. This is pretty much just algebra. So limit h approaches 0. I have negative h, because 3 minus 3 here, negative h. And then that h on the bottom, and then we have 3 plus h on the bottom. So taking the limit as h approaches to 0, I can just simplify this. H approaches 0, negative 1 over 3 plus h. Now you can plug 0 in for h. We ended up with negative 1/3. Okay, so this is the slope, and then finding the equation is quite easy. So you will see that the equation, so we have, I'm going to use the point slope form this time. So y2 minus y1, so y minus 1 equals to, the slope is negative 1/3 x minus 3. And then when you simplify it, you're going to end it up with x plus 3y minus 6 equals 0. And that's our equation.